Okay, Kermit Weeks here, Fantasy of Flight. Driving along. Going to go do a little bit of checking up on Kevin Kimball and the Vega project. Got a couple of tail feathers in the back there, vertical fin and the rudder. He said he needed them to, fit. He's got the fuselage diaphragms kind of getting all laid out, putting some stringers in and stuff. Pretty exciting. Oh my God, he's got some skins made, and I've not been up here to visit since he's been doing that, and so this will be the first time I've been at the shop since he really started getting going on everything. So I'm pretty excited. Could have flown up, but the pieces wouldn't have fit in the airplane. So anyway, it's been a nice drive, and looking forward to it. Okay, so here we are coming up to Kevin's little airstrip here. Pretty cool. And last time I flew in here was with the Stinson L1. Came out, did a little bit of a check. Nice little grass strip. Anyway, so we're coming out to check on the Vega. This is gonna be pretty cool. I've seen a lot of pictures, but I haven't touched any real parts except the ones that I'm about to deliver. So anyway, here we go. All right, there's Kevin. I will just pull right up like I own the place. All right, here we go. What's happening, man? Yeah, good. I just didn't go quite far enough.
It's been a lot of years since you've driven here.
Oh my God! No, I think I remember driving here one time
when you first had the book, the GB book finished, and you came up and brought me a copy, and we talked about it.
Darn. Good.
I think that was the last time.
And then I flew the Stinson in,
right?
And anyway, no, cool. I'll have to bring the S-39 up here one day.
Yeah, heck yeah.
Oh my God! Well, the pictures I've been seeing are freaking awesome.
Good. Yeah.
Cool. So let's see what we got here. God, it's been a long time. Oh my freaking God. Man, that is a lot of work in that. Oh man.
And it's laying over knife edge. This is the top.
Yeah, okay.
And so this is the right side up here that we're looking at. That's the way the factory did it, had it laid on the side.
That is so cool. Oh my gosh, and these little things you go, oh, that's just a little part. Oh my God, and then you realize how much time and effort goes into that.
Every piece, just stacks and stacks of wood and putting it all together. What Cal's doing here is these are the original rods.
Yeah.
Came out of the fuselage. You can see got part numbers on them and McWhite stamped in them, the manufacturer. And and they actually work kind of like the pre-tension rods in a concrete structure in a beam.
Yeah, okay.
There will be some wooden beams in here that these will tighten up against and load and give everything the stiffness, because the wing cutout is a huge hole in the top of the fuselage.
Right.
That gives you that strength.
So that's airplane rebar.
Yeah, exactly. Yeah.
Wow. So this doesn't go back on, does it?
No, it's just on there. That was cut off the top.
Right, to keep the
hold
curve.
The skin while we're getting the skin.
Okay,
yep.
So this was all, whatever was caught up, this was
correct.
The
drop.
The cut
the waist
thing, the waist was filled in with that.
Right. And then what we did is we have little marks on here, and you can see on this one, on here, a little pocket, and that's where this one will get cut off as well, because the wooden beam that comes across through here is one piece to make the wing opening. So all of this material has to be gone for the wing to rest on here.
Okay.
And then
so does this get something bigger here, or?
It's here's an old one. Yeah, and so it's a big wooden beam that spans this gap. This is actually one for here. Goes in this position. So it actually spans that gap.
And save all this stuff too, because we'll either use it to archive, or maybe one day we cut the pieces up and you know, sell it as a souvenir or something. I don't know, raise money for some charity.
We had hoped we would be able to use some of these, but when you look at this, you can just see that it's all split and kind of.
I mean,
it's only 100 years old.
Yeah.
Yeah, that's it.
Almighty. Yeah, we're almost there.
I know.
That's the scary part.
Yeah, so this makes the cockpit opening here. Gives you the definition of that hole.
Oh my gosh.
So your head will be about right here, facing that way when you're flying.
Yeah.
That's the position. Yeah.
Wow. Got the little things in there
All the
for
bonding strips and everything.
little sideways view there, the top and the bottom. God, that is just gorgeous, Kevin. Oh
But
my freaking God.
It's kind of like when we look at all these diaphragms, you can look at the size of it. It's not big enough. You know, did you make it full size? And we keep thinking that way when you look at it. But it's kind of like when you go to a house or a building that's being put together, and the slab is laid out, and you stand there and you look at it. This isn't 40,000 square feet. This is really tiny. And then when the building actually comes together, then it has volume. And
it has volume, and then you start putting furniture in it,
and it's gone.
And it's gone again.
Yeah. So I think that's what's going on here. It just kind of, we've been staring at these parts so long, it doesn't look like it's even full size, but it is.
Gosh.
It's not a very big airplane. You know, you're inside, you're side by side, but your shoulders.
Yeah.
It's cozy.
But it's so pilot in front, like 5 or 6 in the back.
It would be 6 in the back if somebody sits on the commode. Otherwise, it would be 5 in the back.
All right.
And then pilot in the front. And the pilot is centered in the cockpit. It's not left or right or anything else. So you sit. Yeah.
10
you go.
inches on either side, like on the bench either side of the room.
Yeah.
Unreal. Oh my God, man, that is one massive deal. And then this one
is plated
on both sides.
Right.
So that's the front spar.
Right. And the landing gear attachment here for the shock strip.
Oh, I see. That's okay.
And on the early versions, they didn't have this plywood plating on them. They just had small plywood plates like you see on diaphragm 6 there. And then as they went to the bigger engine,
it's tapered as well.
Right.
Wow.
And it's back to flat here, and then it tapers from here up to there, and then flat again, parallel up there.
Right.
So the entire part was made this thick, and then we machined this surface off, after doing the outer shape.
Wow. And obviously something fits in there.
Right. On this diaphragm 4 and 6, you see that? There's both places.
Right.
There's actually another layer of skin that goes as a doubler on the inside. So it's a band of the skin, which we've got made over there. And it'll go on first. And so it makes the skin double thickness right here.
Wow.
And double thickness right here where the high stress points are. Landing gear attaches here and here as well. So they put a doubler in the skin there. Now on the low wing airplanes like the Sirius, the cutout is really huge, about this deep in the belly. It's real deep. Because
the wing goes there.
Right, they flushed in the wing to the bottom.
Wow.
And when they did that, they did this doubled skin from about that station there all the way to the firewall. So it's a double shell up front.
And how thick's the skin?
Just under 3/16.
Yeah, okay, under 3/16.
Yeah.
So let me ask you this. I mean, we were fortunate enough to find a pretty good number of Vega drawings and stuff and borrowed that other people had and stuff. How much is out there for the other airplanes? Because at some point, everybody's going to say, "Yeah, build something else."
There's a considerable amount of data out there.
Really?
Yeah, and when I went to California on the trip and visited with Walt Bowe, and all the data that he had,
which was from the auction of
Desmond.
Yeah, Desmond.
Right. So I looked at all that, and I made a lot of copies of the Air Express drawings and some of the Sirius Altair drawings. But my time was limited, so I didn't have time to get everything. But I would say he's got a couple thousand drawings out there.
Wow.
And we came back with like 800, something like that.
Oh, that's awesome.
So, but there's a lot of data out there to be able to. And these parts are common. This part on a low wing airplane, it's still tapered. But they put it in the airplane, they flip it over, and put the taper to the top, and use the thick part at the bottom. So pretty cool how they can just utilize all the same parts, same tooling.
So the obviously for electrical stuff, but are they actually using that in place of wire or what?
It was the low freq radios in the day. All the metal got bonded together to make sure it didn't have any static and any interference. And then there'll be little pieces of copper that'll solder to that and go up and pick up the fittings or the window frames, those type of metal parts. And then for the tail, the actual tail, yeah, there'll be a piece that'll run up the back of here and come up and tie to that.
I'll be darned.
And then it's actually used for the ground for the tail navigation light. So it actually will be the ground connection for that. There'll be a single wire. We do it originally.
So this is the back of the cabin, and that's where the toilet goes, I guess.
Right. It would be over there.
Yeah.
Cockpit door is going to be this big. Yeah. From that rod down to probably down in here. That's where the cockpit door will be. And then the toilet's here. And that's on the left side. And then on the right side will be a baggage back to this wall. So it looks like there may be a provision for like hanging a suit bag or the boss man's coat, that kind of thing.
Is the toilet something that was formed specially, or is it made out of wood or something?
It's made out of spruce, Sitka spruce, laminated and machined. The toilet seat.
Oh my God!
And then the actual can itself is a removable toilet box, basically, that has a lid, and you can put the lid on and take it out and service it.
I'll have to get one of those little signs like out in the Ford Trimator.
Do not.
Don't use the toilet over populated areas.
Right. And then it has a little slab sink that goes in the back wall and actually hinges out of that back wall.
Oh wow, this is gonna be too cool.
It's pretty cool.
Did I hear you say you found one of the little typewriters for the?
Yeah. There's one of the guys who's been following you on Facebook, and he told us where to get some of that stuff.
That is too cool.
Look at it sideways. Too cool. And this is for the, obviously, elevator and rudder cables to pass, and then the tail wheel trunnion pivot shaft bolts on here, and then the tail wheel assembly comes out through here. There'll be an opening in here. These holes are for a bracket, and I sent you the pictures of that where it was cracked. We can get that bracket and look at it. But the original bracket, actually, someone over tightened the bolts and folded in the legs and cracked the bracket.
I'll be darned.
So what you can see in here, you can see the crack, and then the crack running along here. That's a crack all the way there. Yeah.
Is that something you can weld, or?
I don't think we can on this particular one. You can see how it's bent.
Yeah.
And
might be easier just to.
We're gonna make a new one.
Yeah, and make it, instead of cast it, just CNC it.
Right. That's what we're gonna look at. I've got a guy giving me a quote on it now.
I'll be darned.
So what they failed to do on one of the repairs of the airplane in its life, and I don't know if it happened in Mexico or when. You see the 3 larger holes here that would get bushings in here to keep it from compressing the wood too much?
Yeah.
Those larger holes weren't there and the bushings aren't there. So then the wood was compressed by over tightening the bolts and pinched this, and that's what broke it.
Oh, well, I'll be darned.
And what this does, it sits here, bungee cords wrap around this and hook to the tail wheel unit, and that's your suspension. So we want this to stay intact because that's your suspension.
Yeah. That's cool.
But
that's awesome.
this is actually 1931 version. So when it got the bigger tail, bigger engine, and all the updates, it got the beefier bracket, which.
So when you say I can see the bigger tail for the bigger engine, but so what was the original engine to the next one? Because this thing's got about a 425 horse 1340.
Right. I think originally it came out with a 975 300 horsepower.
Oh.
And so the nose was 8 inches longer, and it had the real pointy spinner, the whole, like almost a Spirit look.
Really.
The cylinders and everything.
And then 300 horsepower for this would not be.
It's pretty anemic.
But still, but when you think about it, 420 for hauling 6-7 people around.
Yeah.
Oh my God.
And 100 plus gallons or 200 gallons of gas.
Whoa, that's actually amazing.
It's a big fat wing, which does a lot to help it out.
Well, I tell you what, while I got you here, why don't we go, let's go grab the parts out of the car real quick.
Okay.
Okay, now that I'm thinking about it, because I just remembered that.
Yeah.
No, not at all. I just came around the loop, and there was hardly anybody.
Okay.
Yeah, so probably, yeah, just, there you go. I just slide that out. That little vertical fin, and that's the rudder there. So Kevin asked me to bring these up so they could basically make sure that it fit the fuselage as it slowly goes together. Great.
So this will help us out right now because there's a mating bracket that picks this point up and another bracket on the front. So we need to just make sure that we locate all that to match the fin.
Cool. Good.
It's been a while since these parts have been up here.
I know.
Yeah.
Show me some of the equipment y'all were using. I think I'd be fascinated by it. You know, like
Sure.
the mills and your CNC stuff, and do you actually do all the CAD design here?
Yes.
Yeah.
Yeah. I can show you all that in the office. We actually, Kallin got some parts here on the machine ready to cut out, but basically we've got typical woodwork shop type stuff where we've got a chop saw and a table saw.
Yeah.
We've got a thickness sander here that we can.
Yeah, that's pretty cool. That I don't have. You know,
It's
got
pretty
all this
handy
stuff.
because we have a plane, which is nice for bringing bulk lumber down to size.
Right,
but when you start working with thin stuff,
Yeah.
it just rips it up and shreds.
Yeah.
So a thickness sander was something we bought for the project.
Yeah.
To be able to do
Awesome. Huh.
that. And then we were farming out some of the CNC work, and then we just got to where we needed to do it ourselves.
So is that all for this is like a CNC router?
Yeah.
Okay.
Yeah.
That's awesome. Well,
So it's got a tool changer on it, so we can load in 8 tools, and so it can run and drill some holes, switch tools, come back, do it, cut something out, do the different jobs. So we've cut the perimeter of all the diaphragms out, all the plywood shapes out with this, drilling all the holes, everything.
And what's something like this cost?
About 40.
Really? Okay.
Yeah.
Fascinating. And I would assume they have different. I had one of the original CAD key. I had that back way a long time ago, and I was playing around. That would have been in the 80s, okay, early 80s. And anyway, I was playing around with that, but so there must be different programs. Do the programs all adapt to any machine, or is it like, different internet channels on the internet or something? I don't know.
There's for CNC programming is a G code is the common language that's used.
I see. Okay.
And so then, if I'm using SolidWorks or he's using Fusion or whatever the package is,
I see.
you then use the CAM package to program after you design your parts.
Right.
To run the program for the tool pathing, and it outputs the G code, which is a series of commands and then decimal numbers to tell it what to do.
So different CAD packages could adapt to the same machine.
Correct.
I get it.
So
That makes sense.
I can sit there and draw something up on my computer and send it to a buddy that has a regular mill, and he can cut it.
I see. That's really cool. That's pretty cool. So obviously it's got little T-slots here for clamping different things down. Those are like
we also
milling
have
machine.
vacuum.
Okay,
So
that sucks.
Yeah. So we actually can hold the material down with the vacuum. If you don't have you're doing like a sheet of plywood or something like that, and you don't want to have fasteners in it because you're cutting it all out, and you put a sacrificial board on top of here, and then you cut to that. You call it a swirl board.
Right. Well, okay, but if you put a sacrificial board on that, then what do you put the plywood on? How do you hold the plywood down? Just clamps on the outside?
If you use MDF as a sacrificial board,
What's MDF?
it looks like particle board, this kind of stuff.
Oh yeah. Okay.
So
you
use that, and it comes with kind of a slick surface on the top and bottom. you machine that off. You put it on the machine and suck it down,
Okay.
cut that off, and now this is porous. And you put it on there and you suck right through it.
Oh, I'll
And
be
then you
darned.
we were holding down the 16 plywood, 8-inch plywood that way when we cut out all the shapes.
Huh.
And what we've done here, just not to use the vacuum, is we've clamped it down. And this is some 1/2-inch thick spruce that we planed down, and that's for the dust collection. Yep.
Yeah.
And then we've got, we'll get cut out of here, will be 4 parts, 2 on this one, 2 on this one. That will be the reinforcement around the stabilizer opening on the side of the fuselage.
Oh man, that is too cool.
So
were you? No, because I mean you came from an airplane background, but you did a lot of boat work, and that's really kind of where a lot of the wood stuff really got expanded upon as far as talents and stuff. So were you using all this back when you were doing the boat stuff?
Right.
Okay.
Right.
All right, that's great. Good for you.
So what we can do is we can do it. This is a kind of a short run, so
Yeah,
we can do a demo run. I'm
absolutely.
actually cutting this for you, so you can see it work.
Awesome, go for it. Do I need some glasses?
No, you'll be all right.
All right.
You want to push the go button?
Oh, let me push the go button.
Hit that play button.
Here we go. All right. So it's going down to pick up a tool. Where was the tool? Oh, there we go.
I'm gonna put that one away.
Oh, I see.
That's the setup tool. So we'll put number 1 away. Next one. And we did all this right. It'll be spectacular and fun to watch. If we didn't do it right, then it'll be spectacular.
Yeah.
So now the spindle started. It's turning count about 16,000 RPM.
Wow.
Yeah. Cut the groove in, slowly ramp down, and now it's going. Now we're going to go back and make another pass. And what we're actually going to do is go around the perimeter most of the way through, but leave it attached, and then make a second pass where it'll do the cut all the way through on the top and bottom edges, but leave it attached on the ends. That way the part doesn't go flying off the
Yeah,
table.
and then you just.
Then we just saw the end.
Yeah.
There's different styles of the router bit. You got upcut, downcut, and what they call a compression bit, which is kind of a combination. So that bit, the very tip of it is made to lift up on the material, and the rest of it pushing down. So that's why it's leaving all the cuts in the road.
So when you say upcut, downcut, how is the blade ground?
I'll show you one of the bits.
Yeah. Okay. Oh.
It actually has the helix changes direction on the way it's made.
Huh.
And it's good for when you're doing something like plywood, so that you don't rip off the pretty surface of the plywood. You're pulling up from the bottom, keeping that surface clean, and pushing down from the top, keeping that clean. You see the helix is running in that direction on this, and then now this runs the other way. So 1/4 of an inch of it is in cutting up, and then the rest of this is pushing down.
so it must have different thicknesses for how it's ground. I see, okay.
Because we only have a couple of screws in the wood, that's where you're getting that harmonic. This wood's vibrating a little bit. Acting like a reed. Now it's got one more to do the outline on. And then it'll do it's gonna come back and do a final pass. I don't know which order, but it'll do this groove, all of these, all the way through, and leave it partially attached here.
Right. So how much do you leave? Like
About an 1/8 inch.
about an 1/8 inch. Okay.
Yeah.
Huh.
These are some of the parts we have to put on the fuselage before the skin. And it defines where we cut the hole for the horizontal stabilizer to come through.
Huh.
Not as noisy now. It's in the middle of the board instead of having that little thin piece acting like a reed out there.
Right. Yeah. Well, you're cutting an 1/8 inch, but you're also going into the other piece as well. So. Yeah.
And we decide how far we want to go in.
Right.
We can say 5 thou. We can say 50 thou.
Yeah.
Whatever we want.
Huh.
It doesn't call in sick. Usually.
Yeah. But they do break.
They do break, but
And when they do, they usually cost a lot of money.
Right. It'll work, endless hours doing some repetitive stuff that is, just too monotonous to keep focus on. And it's really nice to have that repeatability and get everything square. And on the firewall station over there, where all the engine mount holes are drilled in, all that was done on here.
Oh wow!
So everything's parallel, square, and the right size.
Huh.
Ready for the next job, whatever that may be.
So they cut into this board slightly. They basically left the ends here about 1/8 of an inch. And these are actually about a 1/2 inch too long. Kevin said they're going to trim those later.
Let's see.
See if we got all the way through?
Yeah, I can see the flow with it.
Yeah.
Too cool. Wow.
So when we look at the end here, you see that it's still attached.
Yeah. Yeah, about 1/8 of an inch.
Mm-hmm.
Too cool.
And that, each one of these, so this is the two upper,
Yeah.
so that would go on the fuselage here. So one of these would be, approximately there, this one. And so it has to, we have to cut notches in here.
And so what does this do? This goes,
This is the horizontal stabilizer comes through here, the vertical fin sticking out this way.
I can't remember, was the horizontal in one part?
One
or-
piece.
One piece, okay.
Yeah. So what happens after this, these go on, and then after the skin's on, we come in and cut this opening out to these rails, and it eliminates this piece, a section of this diaphragm goes away. And this is now a big opening for the stab to go through on each side.
Oh my gosh. So a lot of this that you've built through here with the stringers is just to get it in place, and this is, some of this is going to get cut out.
Right.
Oh my gosh.
That's how they did it.
Oh my gosh.
Like that.
Yeah. The stab is on jack screws for the trim adjustment.
Huh.
It's on a, there's actually a rack.
But it goes behind here. This all stays.
This one
Yeah.
stays. This is the only one that gets cut.
Yeah.
Well, this one gets cut too, right?
Yes.
Yeah, 15 gets cut through.
So is there something back here that stiffens that up again?
Yeah, there's quite a.
Oh my God. So so these are the two top pieces, one for the right side, one for the left
Correct.
side.
And they'll actually get tortured just a little bit, twisted,
Right.
and bent into place.
Right,
So
okay.
we'll mark out where we need to cut them, and we'll take the hand router and we'll route out the right width notch for it right here.
Right.
And there. And then once they fit in and we glue them in, there's actually another stick that goes between the two here to support it,
Right.
so that when you cut this out later, it doesn't go crazy.
So let me ask you this, was there a reason, because some of these, well, you made them all initially, and then some of these you notched out on this machine or
Yes.
this machine?
Right.
So then why didn't these get notched?
Well, I did these to the drawings,
Right.
and the drawings had these notches.
Right.
The drawings didn't have the notches here, and
So
I
it
could
was
have
a
put
fit
them
later.
in.
It was a
Yeah.
custom fit later.
Right.
Okay.
Right.
Okay.
So I think we could have done it with the CAD
Yeah.
that we had.
Yeah.
but we'll
When
put
we
it
do
in.
like 10 or 12 more, then
Yeah.
that's what we'll do.
Yeah, it'll be dialed in. Yeah, on the rest of them.
On the rest of them, yeah. Oh my gosh.
So there's these set of fittings, we kind of call them a horse collar. That's what we call it.
Okay.
And
Looks like a brake to me.
right, this is an original. You see the
Okay,
original
yeah,
casting.
yeah.
This was made, we think, by GE
E, and so are
when
these.
they had it, and these are
Huh.
made by. These should be a casting as well, not a big chunk.
Right, right.
So these, there's a clamp in the way here, but this fits in here and
Right.
comes up to the top, and then that one to the bottom, and then those span the gap and make that's the elevator attached, this elevator spar through
Right.
here. So the way that these attach to the fuselage, I can show you all this in the computer too.
Yeah, cool.
And it goes in here, and then through the skin are some bolts that go through this way and go through these holes. And that holds these horse collar pieces on. Then coming off the front of that is some more brackets that hold the fin. The rudder bearing for the rudder shaft is on those. They all bolt in. And then off the back is the elevator parts. So these brackets all stack up in here with this to get you the full system. This is the upper one. So this will go in here, mounted to this,
Oh my gosh.
and then the lower one down there.
So with other Lockheed designs of this type, I would assume things like tail wheels, tail feathers, those fittings were probably the same for the airplanes. It's only where you got a wing on the top or one on the bottom and things like that that they had to change.
So on the lower wing airplanes, they built the spars differently, and it has dihedral instead of the top wing's pretty. The high
Right.
wing airplane's pretty flat.
Right.
The lower ones had dihedral.
Huh.
They had some more stuff in them because of the landing gear, maybe.
Right.
If it was a retractable one like on an Orion.
Huh.
But most of this stuff would be the same on the wooden airplanes. On the aluminum version airplanes, on the Detroit airplanes, there's some similar parts, but because they're fastening to an aluminum structure,
Right.
it doesn't have to do, you
Huh.
don't have to go through some of the pains of getting a hard point because you're building it out of a different material.
Yeah, so what Kevin was talking about is the fact that there was some what they call Detroit airplanes that were built that had metal fuselages, So how did that come about? Because I'm not familiar with the history.
Uh,
Because these were all built in Burbank
Correct.
at Lockheed.
Right. So Lockheed went into bankruptcy, and the Lockheed brothers, lost the company. About that same time, the Detroit Metal Plane Company went into bankruptcy. And somebody out there will tell us the name. I can't remember off the top of my head, but the Lockheed brothers were raising funds to try to get the company back. And they had raised the story I heard, about 50 grand, and they figured they needed about 100 grand to get it back. Another guy was shopping it as well, and he also shopped the Detroit company. And he bought that, and then he paid 40 grand and got Lockheed. So then he combined the two and turned it into the combination company Lockheed Aircraft that it was at that point. But then that brought in the metal plane technology. So I think there were 5 metal fuselage airplanes, combination of Vegas and some of the low-wing airplanes.
Right.
And when you look at those, it's almost as though it's a known design. Let's try these new metal techniques on something we know. And we can have known performance on all wooden Vega. Let's change the fuselage out, develop this technique.
Wow.
So the last of this series was the Model 9, and then next came out the Lockheed 10, the twin, all metal. So it was kind of those were transitional airplanes to bring the metal technology into Lockheed. So maybe if the Lockheed brothers had gotten the company themselves, would the Detroit metal influence have made it into Lockheed?
Yeah. No, I think we would have seen a wooden Constellation. That's what I'm thinking.
That's
what I'm thinking.
Yeah. I hate to have to rib stitch that one.
That's right. That would have been a no smoking plane, though, I'm just saying. That is too cool.
So the fin, that's why we had to make this piece early on.
Right.
The rudder, and then the fin spar goes through here. So now that you brought the fin up, we can make some measurements. We'll get those fittings mounted in here, the pieces back here, which we use to align this. And then that'll give us the measurements on exactly, double check our positioning on the bracket that's here, the holes that are already in for the front fin mount. Just make sure everything's going to work.
Yeah, I was just going to ask you if this got spliced in, because I remember when this did, and I just saw the splice here.
Yeah.
Because I remember you making this piece in one of our posts,
Right.
but it was only about that big, and so
Yeah.
I answered.
Yeah, so it's scarfed right into it, right there.
So show. I have not seen these beautiful skins. Where are these freaking unbelievable skins?
Let's take a look.
Oh wow!